In this video, I'll be covering the vulnerabilities Malectrica discovered and reported in Foxycart. Our findings could result in theft of credentials, the ability to spy on transaction details, and the collection of personally identifying information, such as home address, phone number, and the last 4 digits of the victim's credit card, which in turn could be leveraged in doxing, identity theft, or the potentially lethal practice of swatting. Before we begin, Foxycart is a service that hosts carts and checkout pages, intended for easy integration with existing websites. It's relatively popular and has processed over $2 billion USD worth of sales. We identified 3 vulnerabilities. One was standalone and the other 2 had to be chained to achieve significant impact. They were a redirect issue, session fixation, and Malectrica's personal favorite, a race condition. The first and more minor of these issues was an interesting redirect bug that could be used for phishing. Now, I know what you're thinking. Interesting redirect? Open redirects frequently rate low on impact scoring and are occasionally left intentionally in web apps as a design feature. However, the interesting thing about this vulnerability is that it isn't exploited via URL parameters, but rather the referrer header. This has its own unique pros and cons for an attacker. The main disadvantage is that the attacker's site must be visited by the victim for the attack to occur, whereas, with a regular open redirect, they are generally linked directly to the vulnerable site. The main advantage, on the other hand, is that if the victim hovers over the link on the malicious site, it will appear perfectly normal, with no suspicious parameters. In the context of Foxycart, the redirect is not immediate, but happens after clicking the Continue Shopping button, which can strengthen the attack by leveraging trusted UI elements to manipulate and deceive the victim. After seeing that clip, you may be wondering how our researcher, Witchdoctor, was able to pull that off. If the victim is navigated back to the URL in the referrer header, should the same content not be displayed? However, we are serving different content conditionally, and in our case, we use the Flask app to achieve this. His first thought was to check the referrer header of incoming requests and determine whether our site was navigated to from the target store. This turned out to be a dead end, because the no referrer attribute was set, rendering this method impossible. His next idea worked much better. He simply set a session variable to be reflected the first time the page loads, then checked whether it was present before determining which content to serve. This isn't a perfect method, because we don't actually detect the victim's origin, just that it's at least the second time that they're visiting the page. Regardless, it's good enough to work when the victim simply clicks the phishing link and then clicks Continue Shopping. To resolve this issue, the website configured in the Foxycart settings should be used for the Continue Shopping button instead of the referrer header. This vulnerability was closed as informational, which means we didn't get a bounty payout for it, as redirect issues often are. But we thought we'd share it regardless, as we suspect many of you might not have encountered the idea of non-URL parameter-based redirect bugs before. Now for the meat of his findings, the chain. He noticed the parameter you see on screen named Foxycart Session ID, or FCS ID. He manipulated it and observed the response in Burp Suite. Sure enough, it was reflected in the response as his FCS ID cookie. This is called session fixation, and it's dangerous because an attacker can leverage it to issue a session for the affected website in a victim's browser. In some cases, it can even lead to account takeover, or ATO. If a site's logic maps the current session ID to account data rather than issuing a new authenticated session, an attacker would be able to fixate a victim's session, refresh after they log in, and access their account. While that wasn't applicable here, one thing we could do with no additional exploits was spy on cart activity. But that's relatively minor, so he continued to keep looking for impact. The impact came when he was playing with checkout functionality and saw the information on the receipts. But there was a problem. You can only view a receipt once before it's erased, or at least that's the intended behavior. However, due to a race condition, he was able to access them regardless. A race condition is a bug that occurs when multiple threads, or in simple terms, instances of the same functionality running simultaneously, try to access the same data at the same time. This can lead to many issues, such as TOC/TOU, time of check, time of use, partial construction, and limit overrun. TOC/TOU vulnerability essentially means each thread of a vulnerable functionality takes a value and stores it, performs a check to ensure it's valid or safe, and then uses it for something. If concurrency is handled unsafely, an attacker can cause two threads to open, where, in the first, a valid value is submitted, and in the second, a malicious value, causing the safe value to be replaced with the malicious one, after the application has determined those values safe. Limit overrun race conditions occur when multiple threads read a count, increment it, and write a new value. For example, say 3 threads read the value 0, add 1, and each write that value is now 1. In the case of Foxycart, however, the impact of the race condition that was found was simply that data could be loaded multiple times before it was deleted. And let's look at a simplified representation of what the code for the vulnerable functionality might look like. Here we see the function loadReceipt, which takes an FCS ID and loads the information for that user's cart. Directly below is the deleteReceipt function, which takes the same FCS ID and deletes that data. The problem here is that between these lines there is a race window. If 2 threads were to request the receipt at once, thread 2, the attackers, could load the receipt before thread 1, the victims, could delete it. And the solution to the race condition would be to use a thread lock to prevent multiple threads from being able to access the receipt simultaneously. However, the more vital issue to address the underlying cause is the session fixation. To review, that's a referrer header unsafely used for redirects leading to phishing. A session fixation that allowed us to spy on carts and by a race condition on checkout to steal data such as full name, home address, last 4 digits of your bank card, and contact information. That about wraps it up for this video. Like and subscribe if you want to see more, join our public Discord server if you want to hang out or get involved. Thanks for watching, stay vigilant.